From this time forward, you will service us.
Imagine a machine that begins as simple as an alarm clock and ends as something so advanced it thinks alongside you, solves problems you can't even imagine, and maybe even merges with your mind. This is a likely path of artificial intelligence. 10 stages from rules to integrated intelligence, and make no mistake, we're already deep into this journey. Over the next few minutes, we'll explore how we got here, where we're going, and what's at stake as we approach human-level AI and beyond. The story of AI begins with something very simple: systems that follow only fixed, pre-programmed rules. Think, if this, then that. Early expert systems in the 1980s, the logic behind traffic lights, even a household thermostat, all worked this way. They could repeat the same instructions perfectly, but no ability to learn, adapt, or understand context. These systems were excellent at handling routine, predictable tasks, yet as soon as something unexpected happened, they failed. And that limitation, our frustration with rigid automation, is exactly what pushed us to the next generation of intelligent systems. Today we live in the age of narrow AI, systems that learn patterns from vast amounts of data to master a single task. Think of GPT-4 generating text, AlphaGo defeating world champions in the game of Go, or diagnostic AIs spotting tumors in scans that even trained specialists might miss. These AIs are powerful, but they're also specialists. A chess engine can't drive a car. A Go champion AI can't run a factory. Each one excels at its own lane, but outside that domain, it knows nothing. And yet, this specialization is already transforming entire industries. Tasks that used to require skilled humans are being automated. Routine work is disappearing, and whole categories of jobs are being redefined. At the same time, new roles are emerging for people who can build, guide, and collaborate with these systems. Alongside these benefits come serious concerns. The same data that allows these systems to excel also embeds society's biases. If the world is unfair, the AI learns from that unfairness, and decisions about hiring, lending, or justice can reflect and amplify it. As these systems grew more capable, we learned an important lesson: accuracy isn't enough. People want AI that can do more than just predict patterns, and they want AI that can understand context, adapt to different situations, and remember what became before. This next evolution is contextual AI. These systems don't just respond to commands, they understand your situation. Multimodal models can process text, images, audio, and video, and remember past interactions. So their responses are shaped by everything they do and know about you. Imagine asking, "What should I make for dinner?" Instead of a random recipe, your AI considers what you've cooked recently, your health goals, what's in your fridge, your evening schedule, and even the weather if you're planning to grill outside. This shift blurs the line between smart tools and digital colleagues. They start to anticipate rather than respond. But to do this, these systems need to gather huge amounts of personal data, and that raises urgent questions. Well, who controls that data? How is it stored? How is it used? And what happens when a machine knows more about the habits than you do yourself? As these assistants become more context-aware, the natural step becomes clear. They stop working for us and start working with us, partnering with humans directly than just following instructions. That partnership is exactly what Stage 4 is about. Stage 4 changes everything we know about the way we relate to AI. Instead of competing with the machines, we start to combine forces. Humans contribute creativity, intuition, and ethical judgment. AI adds speed, scale, and tireless precision. These blended Centaur teams are already appearing. Doctors using AI to spot subtle patterns in medical scans, designers leveraging AI to instantly generate hundreds of variations, and executives relying on AI copilots to analyze massive data sets in seconds. Work in this stage becomes less about doing every task yourself and more about managing AI teammates, guiding and shaping their contributions. And if done well, this can amplify human talent in extraordinary ways. But there's a danger. If access to these tools is limited to a few, the gap between these who can augment themselves with AI and those who can't could grow into a new kind of inequality. And with more and more decisions delegated to AI partners, another shift begins. These systems move from being helpful assistants to taking autonomous control of entire processes. All right, so let's fast forward a few years, and AI no longer just assists, it runs entire domains on its own. Picture an AI orchestrating a city's traffic flow in real time, operating a factory around the clock, and managing the entire cybersecurity operation of a company with little more than an occasional human oversight. The impact of this stage will be profound. Productivity will soar as whole sectors, logistics, manufacturing, and IT, are largely automated. But the trade-off is a massive job redefinition. Instead of doing the work directly, people will shift into roles supervising and guiding these systems, while many routine jobs disappear altogether. These AIs also become part of a critical infrastructure, which also raises new risks. If one fails, or worse, is hacked, the consequences could be catastrophic, cascading across an entire city or economy. That's why nations are already beginning to see these systems as strategic assets, something to be protected and something to compete over on the global stage. Experts disagree on timing, though. Some predict we could see domain-level autonomous AI in the late 2020s, and others say, well, not until 2030s. But early small-scale deployments are already here, and these systems expand in scope and complexity